What's going on, guys? Welcome back to the MG YouTube channel. I'm Malcolm Graham, CEO of Elite Automation, Elite Properties, and an investor in Tesla. So, I want to talk to you guys about Tesla AI for Robotaxi and the AI for the bot. We just got some new video footage coming out of Optimus robot doing Kung Fu. And I hear a lot of people talk about how the Optimus robot has the same AI as the vehicle. Now, one thing people have to be careful of is where it may use like the same like training methods and the AI and like the way that it learns information and the way that it processes information can be like that same architecture as each other, right? So the vehicle in FSD and the Optimus robot and all of its functionality. Now, the thing against that, where they're going to be completely different, like you're not going to be able to just download FSD into the robot. One, there's a ton of different things. First of all, FSD is completely trained on driving entirely. With that being said, it only understands really the process of driving. Secondly, the way that at least AI in today's world functions, that AI is trained off of specific camera positions. It's trained off of specific camera positions, specific machine outputs. And when I say machine outputs, I mean things like your motor speed, tire rotation, degree angle of steering, acceleration, deceleration, how much regen's applied, if the brakes need to be applied, right? These are all different outputs that the machine of the vehicle has to do. Therefore, none of those things really apply to an Optimus. Now, could you translate some of those things over to an Optimus? Potentially. But the way a vehicle outputs, let's say, for instance, like the brakes, would be a lot different than the way an Optimus robot would output something like hit the brake. So, like, if you physically had an Optimus robot sitting in the seat, it would be a leg action. That the Optimus robot would have to take its leg, pick it up, put it on the brake. Unless it had some wireless communication between itself and the vehicle, which if it had a wireless communication like that, it had to be on like an ultra secure, like encrypted communication where it's pretty much unhackable, right? You wouldn't have a way to be able to like patch into the vehicle, because if not, somebody else right next to you could like hack into that wireless signal. And it's also one of the reasons why I don't think that Tesla really has like a hotspot that you can connect to in their vehicles. That hotspot kind of gives you one more potential to hack into the vehicle, which if you connect to the same network that the vehicle's on, that could be a potential to hack into the network too. So like if you're connected to your home network and the vehicle's connected to your home network, technically you can access the vehicle from that network. But like as the vehicle's driving around, if it's not connected to a network, then if the vehicle doesn't have an active network for somebody else to connect to, then it makes it a lot harder for them to be able to hack it, as there's not a wireless connection established. Now, if you're like at a McDonald's and you connect their Wi-Fi with your vehicle, whatever, then they could hack it. Another topic, not really getting into that right now. But so where Tesla is using the same architecture and the same training methods for FSD as they will with Optimus, they're completely different. It would make no sense whatsoever that they would be able to just drag and drop FSD into Optimus. I mean, they'd be starting completely over with the training, completely. The only thing that like they might be able to say bits and pieces of it, of like it's okay to turn left here, it's okay to turn right here, but even still against that, the one major issue is camera positioning, right? So all these decisions are being made off of like where the cameras are at in space, and also like the number of cameras. So it's analyzing all that data due to those cameras' perspectives. Okay, it's like the equivalent of if you had somebody who's like 4'5" and then you had somebody who's like 6'7", their perception on the world is different than each other, and that's a pretty good example. And we are like the most advanced version of an AI, right? Whereas like AI is not even really there yet. It's probably going to take another couple of years before AI gets to, and maybe up to 5 years before AI gets as good as like a human is, and then things like perception like that don't matter. But even right now, today, if you took AI and you built a robot at 5'4" or 4'5", I mean, and then you built a robot at 6'7", they would probably have to run off 2 different models for the short robot and the tall robot, so that way they're getting training based on their perception of the world. And also too, thinking about it, going back to a human example, we didn't learn the stuff that we learned overnight. You know, we weren't born, you know, 6'7", right? We weren't born that way. We were born smaller. We learned the world around us, and we slowly grew every day, taller and taller, learning the world around us. So it didn't take us one day to learn, you know, what it was like to be 5'4" to what it was like to be 6'7". You know, that's something that, you know, somebody went through a period of time in their life where it was 4 or 5 years, and somewhere throughout that 4 or 5 years, that person that went from 4 or 5 to 6'7", probably was like banging their head on doorways and like, you know, doing a bunch of clumsy stuff that took them time to like be able to learn and perceive the world appropriately, so that way they were making like less mistakes of the world. It's also like another reason why my $75 windshield wiper blade is all jacked up. By the way, I'm in the Cybertruck in FSD right now. I've been in FSD this entire time. Not driving, never drive, but unless I'm just having fun. We had a good time actually this weekend driving it up to the farm at Baja mode. Another topic though, but I jacked up my windshield wiper blade while doing it. Going back to perception. Oh, perception. So that's also a reason why, like, we have things like the Cybertruck. Like, why would the Cybertruck's FSD be like worse than like a Model Y? Now it still functions great. I pretty much never drive, but there's like some weird instances of things that it does that the other vehicles don't do. Why is that the case? Well, there's one or two options. Either you're trying to run the exact same version of FSD that's in like a Model Y and a Cybertruck, which has like no tweaking or extra training done to it whatsoever to optimize for the Cybertruck. So basically the Cybertruck thinks it's a Model Y. It has no like major understanding that it isn't a Model Y. So that's one thing. So you're basically, and this goes back to an example of like a dog. You know, we just got a dog. He's like a puppy still. He's like 1 year old, and he's freaking like 4 foot tall. Well, maybe not 4 foot, 3 foot tall. He's massive. He's a King Corso and Pit Bull. And this dude just like climbs right on top of you and lays on you. He just don't know how big he is. You don't know how big he is. And that's how the Cybertruck feels. The Cybertruck just feels like it doesn't know how big it is, right? And it is because of one or two reasons. Either the Model Y, FSD, Model Y, Model 3, all those models, FSD is all the same model, probably utilizing one singular vehicle like the Model Y, which it probably would be the Model Y. That's why Model Y is Robotaxi right now. And then just transferring it over to the Cybertruck, okay? And then again, there's adverse effects from that. The second thing would be that the Cybertruck is trained on an offshoot FSD, right? So let's say, for instance, you have FSD-Y for FSD Model Y. You have, let's say, FSD-C for FSD Cybertruck, okay? The Cybertruck FSD, it could be being trained as an offshoot. It's still a base model of like Model Y, because I don't know the Cybertruck itself would have even enough data. It wouldn't even have enough data to train full FSD. There's not enough Cybertrucks on the road. I mean, I think there's been like, I don't know how many, a few 100,000 Cybertrucks ever sold, maybe 500,000 or something like that. I'm not sure the exact numbers. Let's see, maybe Grok knows. Hey, how many total Cybertrucks have been sold? Hello, Mac.
Around 39,000 as of last year, though numbers dipped to about 5,000 per quarter lately, from what folks are saying online. It's a wild ride for that truck, isn't it?
All right, thank you. So, yeah, 39,000. That's crazy. There's nowhere near enough Cybertrucks on the road as there is. There's nowhere near enough Cybertrucks on the road to be able to train FSD. So they'd have to take like a version of the Model Y, say, no, this is what you actually look like, and then maybe run that through simulated data. So like, but again, so like that's where the training is different, and it's based on the perception of the vehicle. Where maybe these side cameras on the Cybertruck are at a different at a different angle. Yeah, they're at a different angle to the world because like the vehicle's sitting up off the ground a lot higher, which just makes. By the way, I'm just engaging now so I can park. Yeah, its perception of the world is just different because of its angularity, its view of everything around it. And so then they have to simulate that. They have to basically try to probably take Model Y information and say, here's my perception of the world. Do some image processing to make that camera angle look like it. So they basically re-simulate the image to make it look like the Model Y cameras are kind of in this downward facing angle, which you're going to lose data. You're going to have to crop in to that image. It means basically like zoom into that image a little bit just to get the right camera angle, the right simulated camera angle or whatever, which is still not going to be right, to be simulated. But again, the perception is off. So you can't, going back to the robot, its camera sensors are completely different than like a Model Y to a Cybertruck. So just because of its camera positioning, its perception to the world would be entirely different. If you think about yourself as a human, when you look around inside of a vehicle, you're looking inside the cabin of the vehicle, right? Whereas the vehicle itself is looking on the exterior of the vehicle and is looking as if when you pull up these cameras, you see exactly the camera angles that it's looking at. And that's the only perception that it has of the world. Oh my God. Season change is happening. But the AI that is going to be in the Optimus robot is going to be completely different than it's going to be in the vehicles. And if you ever wanted to give the Optimus robot the ability to drive, it would have to be completely retrained with the Optimus bot sitting in this seat and grabbing this perception of the world. And I think there's also, I got into another video where I talked about like the future of AI and autonomous first, and there's a lot of cool things that Tesla could do inside a vehicle to make these like some really cool workspaces. And that kind of just ties into like perception, where they can have cameras facing in towards the human. And then you could do things like how you're seeing like Apple with their goggles or whatever you're calling them. But all these different AI tools or whatever, where not AI tools, like your AI goggles, VR is what I'm trying to say, VR, AR goggles, where you can like zoom in and be functioning inside like a Mac computer with the Apple goggles or whatever, and be able to like zoom in and do things like that. Like you could be able to have a screen up in front of you and do like cameras being able to face you inside the vehicle. You can do all kinds of zooming and doing all kinds of things like that, which I think would be really, really cool if Tesla like goes that futuristic with their vehicles. I think it would just be cool for Tesla. That, for Tesla to really keep that name of being a futuristic, company, is like have that office on wheels or whatever. But they'll be focused on Optimus for so many more years after this. Another thing that I talked about too in a past video when I talked about Optimus and specifically Optimus and like its AI, that it is almost definitely going to have different AI models running on it, and potentially a singular AI model running on it at one particular time. So it might have the plausibility of like, I'm running an AI model that's for dishes only. I'm running an AI model that's for vacuuming only. I'm running an AI model for taking out the trash only. And it could have more of a program, how do I say it? A program structure where there's like a main program, and in that main program, it calls out like what AI model it needs to use for whatever the task is. So that main general AI program is saying like, what's the task, right? And so whenever you tell it, you say, hey, Optimus, I need you to do X thing. Then it goes, okay, this is what they want me to do. Oh, it's dishes. That's what they want me to do. Now I need to go pull my AI model for doing dishes. Pull it up. Okay, what's my memory of doing dishes? Okay, I need to walk into the kitchen. Okay, I need to be able to navigate into the kitchen. Okay, what are my cues and indicators that I need to navigate into the kitchen? Because remember, everybody's kitchen is completely different. So it'd have to learn your specific kitchen. Whereas like, you can tell a human, hey, go to the kitchen and find me something. They can do that. But like if they don't have any memory of where that kitchen's at, then it can become a little bit challenging. And especially if they don't have any memory of like where do the pots and pans go? Where do the forks and spoons go? I mean, you've ever seen, like, think about anytime you've ever been into a kitchen and you've never been in that kitchen before. You don't even know where to find a spoon. If you ever stayed in an Airbnb and they don't have anything labeled, like, where's the spoons at? Where's this at? Where's that at? You know what I mean? You don't know, again, you don't know where nothing's at. It takes you forever to find something. You don't want the robot doing that same thing. Another thing that's there is you have a few different things. Compute, meaning how quickly it's processing the information. And then secondly, is, oh, I lost my thought. Compute. Oh, and memory, right? So it can only remember so many things. And with the vehicle, you can put a pretty massive computer in the vehicle, right? And have a bunch of hard drives and stuff like that. Now it's going to add weight to the vehicle, it's going to add cost to the vehicle and all those good things, right? But technically the vehicle itself is doing one thing, driving, right? And so if you put that on the grand scheme of humans and what humans do, we're asking the robot to do 1,000 times more things than we are for the vehicle. We're asking the vehicle to drive. That's all we're asking her to do. You know, drive and not wreck. But we're asking the Optimus to do dishes, mow grass, vacuum, laundry, you know, construction, plumbing, electrical work. Like, you know what I mean? Like, as we go into the future and start utilizing these robots for things, general assembly, manufacturing processes, you know, those types of things. So you're only going to actually be able to store a certain amount on the robot because you're just not going to have the disk space to store an infinite amount of information. You know, to store every little detail that you need about like doing something like plumbing, you know, you have to store all your information on like an expert, right? I mean, and some of the data will be way easier. This is the thing about like computers versus humans. Like, for a robot to remember, like, this is the slope angle that a pipe needs to drop at for, like, a drain line, that's super easy, right? That takes the robot no information. Now, where it might become more complicated is, like, I need to put this pipe into this other pipe. I have to glue this pipe. You know what I mean? I have to put my primer on it. I have to put my glue on it. It has to know the information of how thick, and it's the coordination of those motions that actually become much more difficult. It's not necessarily like how much. It's because like 1 inch and like around the entire circumference, like those are all data points that are easy to store in a robot, and they actually don't take much information or much storage space to remember something like that. Like a photo takes more storage space than like some of that information that I'm saying there, like 1,000 times more. But, you know, then it has to do all the coordinated motion of plugging it in. And so these are all things like pieces of code that it has to execute on, or AI that it has to execute on. But it has to also have memory of that execution, right? It has to have that, that memory, that trained, right? It was trained in the supercomputer. It was downloaded to the robot. Now the robot has to remember to do that task, right? It has to be able to recall that memory, which is where compute comes in. But then it also has to be on board so that it can recall it quick enough. Now, there are a few things that could go against that, where if somehow the robot could run off the cloud, But we would have to have compute like so good. People's internet would have to be so good where, the robot is like predominantly. But the thing is, you can't really work off the cloud because like even sending the camera data over the cloud, you're gonna have so much latency from like you sent it over the cloud, and then it'd have to be like the other way around, where like the supercomputer logs into the robot, can see what the robot's doing, and tells the robot what to do, versus like the robot having to upload all the camera data to the cloud. It's more like the AI itself logs in the same way you would like remote into a computer. So if like somebody else is like working on their computer, they're having trouble with their computer, you need to help them troubleshoot. You then get on your computer, remote into their computer, and then you can see everything that's on their screen and control their screen. In that instances, you might be able to like crunch down like the amount of data that's actually being sent over the cloud, and potentially be able to like remote control it, like have the AI, the hive be able to control the robot. But if not, then the robot's gonna have to go through processes of like uploading and downloading information, and that's what I got really deep into that video. And I wasn't really trying to go that deep in this video about that particular part of things, but I was really just kind of trying to touch base and really create that perspective of like how they're so different, and how like even a simple thing like somewhat simple thing, right, from like doing dishes to like taking out trash might have to be a different AI model, right? And it might have to have like a task list of like, hey, I'm gonna do the dishes, then I'm gonna take out the trash, then I'm gonna mow the grass, then I'm gonna do laundry, okay? And with that being said, okay, I have my dishes AI model running in me right now. I'm gonna start downloading the trash AI model while I'm doing the dishes. So when I'm done doing the dishes, I'm ready to run my trash AI model. And then while I'm running my trash AI model, I go to what was next? My mowing grass. I'm downloading my mowing grass one while I'm taking out the trash. And taking out the trash doesn't take much time, so it might need to be starting to work on getting that mowing lawn one loaded up while it's even doing the dishes still. But and then it's saying while I'm mowing grass, I need to be downloading the laundry one. So whenever I'm done mowing grass, I already have my laundry one ready to roll. Because you have to think there's so many sub tasks that are going on with the robot. If you really want it to be autonomous and really do things for you, is it gonna take the lawnmower out for you? Is it gonna put the lawnmower up for you? Or is it just gonna be like, maybe at first, maybe it's not even that capable. Maybe at first, like, you have to like take it out there like a child and like set the robot up, or set the lawnmower out there for it. Say, hey, here's the lawnmower, dude. Go ahead and start mow the front yard. And then it can mow the front yard. And then it can say, hey, dude, I'm done mowing the front yard. Take me to the backyard. And then you got to kind of walk him to the backyard and say, okay, here's the backyard. Mow the backyard now. But all these little subtasks of like putting the lawnmower up, taking the lawnmower out, cleaning out the lawnmower, changing the batteries on the lawnmower, filling up the gas on the gas tank on the lawnmower, like all these different types of things. Those are all sub things that like become really challenging, right? It's a whole nother task basically that robot has to learn how to do, and that's a lot of things that robot needs to know on demand and be able to know how to navigate that situation. What does it do whenever it goes to grab the gas can and one of the kids grabbed the gas can and did something else with it, and now the gas can's not where it's supposed to be at? Now the robot's like, what do I do here? So like then there's that whole like, how does it handle that situation? Does it send a notification to your phone, or does it try to process it to try to look around the garage for the gas can before it sends a notification to your phone and say, hey, gas can's not where it's supposed to be at. I'm not seeing it out here in the garage. You know what I mean? I'm gonna try to look around the garage to see if I can find it. But again, this is like the complexity that one singular task can get into. I'm doing laundry. Where's the laundry detergent at? I don't know. What should I do? You know what I mean? Do I send a notification to the phone saying, hey, I don't see laundry detergent. Can somebody help me out here? It's got to fill up the laundry dispenser thing, right? I mean, like, luckily with us, like a lot of our washers and dryers, like you fill up like a whole gallon of liquid in it, like 52 something loads or something like that. So you don't have to, you know, like an Optimus robot or something like that wouldn't have to interface with it that much. And I also think, one thing I also think when it comes to like on an electronic level, I really think like things like the Optimus robot and all other devices should be like the Internet of Things, right? Should be smart enough where the Optimus, instead of the Optimus wouldn't hit the play button, right? It shouldn't need to. It should be able to say, hey, run the washer. The washer's then also giving a signal to the robot saying, hey, I'm going to be done in 30 seconds. I'm going to be done in X amount of time. You know, so that way the robot knows that like, oh, hey, the washer's about to be done. I need to go over there and not just like not just listening to the audible alarm like a human would. The same way that like we're getting like a text notification on our phones for our smart washers saying, hey, the washer load's done. Or like for me, I have automation set up at my house where when my washer's done, it broadcasts across all of our Google speakers saying, you know, upstairs washer done, downstairs washer done, those types of things. But yeah, hopefully this is an insight on like how the AI models will function within Optimus and how they're, you know, differ from FSD. You know, about the Kung Fu video thing, it's cool. It's cool, the fact that it was running off AI like that. In my opinion, knowing robotics and all that, like, it didn't do anything that impressive. I mean, don't get me wrong, like, it is impressive. But I don't think it was anything good enough to be extremely wowed about. Now, even on a defense mode, if like that, the guy was like throwing punches at it, and it was able to just block literally every punch, and like, the person couldn't get in to do anything, because like the AI model was just so good at defending everything that like he was like black belt, you know, black belt level, but it was like not even white belt level. So again, like if you've seen like that black belt level, then that'd have been extremely impressive. I think it was still very impressive. Don't get me wrong. I'm not trying to downplay it or anything, but I try to be one of those Tesla bulls that like, I don't hype things up that I don't think should be extremely hyped up. Again, if they would have came out with that video and that thing was a fucking black belt, like I'd be like, oh fuck yeah, that's the shit. That is some beast stuff right there. But yeah, again, it wasn't doing that, so you know, here we are. But the other big and important thing is FSD version 14 is dropping today, which is Monday. This video is probably gonna come out on Wednesday, so it'll be a little bit late. I might even switch this video around where it comes out on Friday and make an FSD video that comes out on Wednesday, because especially if I get FSD, for sure if I get FSD, I'm gonna 14, then I'm definitely gonna shift this video to Friday, so you'll be watching on a Friday and not a Wednesday, and you'll be watching the FSD video before this video, but whatever, right? V14 is going to be the path. It's going to be the indicator of where Tesla's going to be at in the next 3 months to 18 months. If the stock and FSD and Robotaxis have become a full-fledged thing all throughout the United States, it's going to be version 14. If it doesn't happen during this version 14, and when I say version 14, I mean 14.1, 2, 3, and within one of the variants of 14, then I have bad news for myself and all other Tesla investors. It's probably going to be another year before they really get there. I think version 14 will do it, though. Version 13 is already so good. They'll still expand no matter what. Just let me add that. They will still continue to expand even if they were on version 13 and they weren't going to get to version 14 till next year. I think they would actually be expanding more aggressively. I think the reason why they're not expanding more aggressively is because I think once they go from 13 to 14, I think they have to do a bit of a pullback, and they lose a lot of work that they've put into things. So that's one thing I think that Elon really does a lot of, is he makes sure there's not inefficiencies where like we put 6 months of hard work into something, and then it's just going to get lost and overwritten because of like version 14 just like it's so much better that like literally everything we did the past 6 months is just like went to the trash, right? So like instead of trying to roll out Robotaxi in like LA and Miami and Chicago and all these other major cities, FSD's only rolling out in Austin majorly. I mean, they have the one in San Francisco or whatever it is. But lost my train of thought. Oh, but they're not expanding in those areas because they would just be too much lost engineering time and like getting those areas prepared. I've mentioned this before, is Tesla FSD is probably to the equivalent of like Waymo right now, in the sense of I think Tesla has to do a lot of manual training and intervention to particular cities to make them robotaxi ready. And Tesla doesn't want to be at that. They don't want to have that methodology when it comes to deploying robotaxis. They want to deploy robotaxis where they flip a switch and then it just works in that area. They do a little bit of validation for a few weeks, a month or two, and then boom, done. Again, I think right now they're currently in a standpoint, like if they wanted to launch in like Chicago, they have to do a lot of training in Chicago, like 3 months, 6 months of training before they're able to actually fully release Robotaxi in that area and let it function perfectly. Also, I was in Chicago like a few weeks ago, and my FSD seemed to work better in Chicago than it works here in my hometown, which makes sense because Chicago is a lot bigger. It's one of the robotaxi cities. So it's highly likely some of these other cities for like the past years have been getting more optimization and more refinement, more specific generalized training towards those areas than like an area like mine. Like it might be a plausibility they've ran like no simulation or very minimal amount of simulation in Evansville, Indiana, and they've ran like trillions of simulations in cities like Chicago's and LA's and all these bigger major cities, you know, because they know the population's there. They know they're going to launch there first. They need that area to work so good. There's going to be such a dense population of Tesla vehicles, robotaxis, and things like that in those areas. But yeah, guys, thanks for viewing here till the end. Subscribe if you did, and go check out some other of the other YT videos talking about Tesla, robotaxi, and other entrepreneurial things we talk about here on this channel. Peace out. Catch you on the next one.